So 8g says determine the values of k for which f of x plus k, let me actually write that down, f of x plus k is equal to g of x has two roots that are opposite in sign. So this question is confusing when we read about it. Most people honestly get confused on what to do, but we basically are looking for two solutions. Or we're looking for the point where if I rearrange this, f of x is equal to g of x and minus k, which means we can shift the graph of g up and down such that it produces roots. What are these roots? Currently, as it is producing these two roots. These are roots, basically points where they intersect. So now we have the ability to shift this function, and we want to see what are the ranges of the, let me use another color. What are the ranges of values of k that we could use such that we produce roots or intersections that are of opposite signs? So two roots that are opposite in sign. Basically, if I shift my function, if I shift it up and up and up even more, it gets to a point where the roots that it produces are now not satisfying the equation, because at these points the roots are of the same nature. This one is negative and this one is also negative. These are two negative roots, which is something I'm not looking for. So oopsie, I'm not looking for this. I'm looking for the point where, you see, just below C is the point where they have the roots that satisfy this condition. One is negative on this side, one is positive on this side. So anything above C would not satisfy the condition. So what does this mean for the value of k? First of all, what is C? The coordinates of C is 0s to 6. It means that we cannot shift our graph any value, we cannot shift our graph by any value that is greater than this value 6. Well, if you're looking at it from this perspective, but when you actually go and compute it, this was only one way of thinking about it. We could have thought about it as moving the parabola itself. So if we think about it that way, then we don't need to necessarily think about inverting k. So let's try again that same analogy. Here we are producing 2 points. So here I'll just try and retrace this function somewhat and then move it up and down. So here, if I move our function below, we see that at this point, at all these points, it's still intersecting twice, right? At this point, it's intersecting one on the positive, one on the negative, still satisfying the condition. But if I drop this point to such a point where it is now somewhere like this, then this becomes an error, because at this point now both of them are negative. Both of the points where they intersect, which is over here and over there, both of them are negative, which is a condition we are not looking for. We want one positive and one negative. So what do? We note the point where everything changes. So if you look at the point C, when that point C here, if I work with that point, when that point C is below the x-axis, so when it's below, so I'm currently holding the point C. Currently I've dropped C by 6 values, by 6, and if I drop it anymore, you can see that now they are both negative, which is something that I'm not looking for. I want one positive, one negative. So basically it has to stay above over here, which means we cannot drop our function by any value of k that is greater than that is smaller than 6. So we cannot subtract anything more than 6, because at this point it just critically, it's at the critical point right there. And if we drop it anywhere below that point, we're getting two negative. We don't want two negative, we want two opposite signs. And if we put it up any higher, it won't change. We'll always have one positive and one negative. We just cannot see it in this case because our graphs don't have an infinite axis. But yeah, that's how you think about the situation. So basically, we are saying that to satisfy this condition, k should always be greater than -6. If we drop it by anything like -7, it won't work. We can drop it down, we can pull it up, but dropping it down has a limit. Pulling it up has no limit. So k just has to be greater than -6 in order for this condition to be satisfied.